morning. This is Ms. Billerbeck, and we are going to talk about 9.6, the quadratic formula and the discriminant. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the discriminant is actually just this section here, b squared minus 4ac. So that is the discriminant. So we're going to learn about that today. So the first thing and most important thing we need to figure out, well, how is the quadratic formula derived from the standard form of the equation when it is set to 0 so that we can find its solutions or roots. So let's start with ax squared plus bx plus c equals 0. We want to divide everything by a. And that gives us x squared plus b over a x and then plus ca. Now we want to move this ca to the other side, so let's just subtract the c over a here, and then and 0 divided by a is 0, so then we're just going to have 0 subtracted by c over a. This section, whoops, that is not the section we wanted to do. We know that this right here is just 0. So we don't have to deal with that anymore. And now we just have a negative c over a here. So what we want to do is complete the square now. So we have x squared plus b over a x. And then we want to add a completion of that square. So we're going to take b over 2a and we're going to square it. And then if we add it to that side, we're going to have negative c over a, and we're going to add b over 2a squared. So b over 2a, this is b over a, and then we divide it by 2 to complete the square, and then we square it. So we added it here, we added it to this side of the equal sign. So we haven't changed the equation, but we've created a perfect square trinomial. So now we can write this as x plus b over 2a squared equals negative c over a plus, and let's distribute this. We have b squared over 4a squared. So if we have that, we probably want to, we'll work on getting a common denominator in a moment. So now what we're going to do is we are going to take the square root of this side. We're going to add a plus or minus right here and take the square root of this side. So when we take the square root of something that's being squared, we free it from the radical. So we have x plus b over 2a. And that equals plus or minus. And actually, let's complete this radical. So we need to have this be 4a squared. So we're going to multiply by 4a here and 4a here. So we have the square root and we have a plus in here. Let me rewrite this section so it's a little more visible what we're doing. All right. So now on the bottom, I have 4a. Let's rewrite this right here, plus or minus the square root. We have negative 4ac over 4a squared plus b squared over 4a squared. So because these have the same denominator, we can now put them together. So let's put the b squared first. So b squared minus 4ac over 4a squared. All right, so we know 4a squared is a perfect square there, so we could just take this out and break this into two different radicals. We could do the radical on top, b squared minus 4ac, and then we could do the radical on the bottom of 4a squared. Well, we know the square root of 4 is 2, so this just becomes plus or minus, whoops, we ran out of room, so let's move over here. So we have x plus b over 2a equals plus or minus, and now I have, when I take this out of the square root, I have the square up here of b squared minus 4ac, and down here I just have 2a. So now what I'm going to do is subtract this b over 2a from this side and subtract it from this side. So when I do that, this becomes just x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So if we want to make this easy on us, that's the same denominator. We can just change this up and put the plus or minus a little higher. And there we have the quadratic formula. Okay, so that's the importance of completing the square. It's a lot of work, but we derived the quadratic formula. All right, so let's find the solutions for this quadratic using the quadratic formula for this. So I want to subtract the 21 and add the 4x to both sides. And I'll rearrange it as I go. So this becomes 0 equals x squared. Then we have plus 4x when we put it into standard form minus 21. So our a is 1, b is 4, and c is negative 21. So we have x equals negative b, which, well, let me write the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes negative 4 plus or minus, and then we have the square root of b squared, which is 4 squared minus 4 times 1, which is a, times negative 21, which is c, all over 2 times a, which is 1. So this gives us negative 4 plus or minus. Then we have inside the radical, we have 16. 2 negatives make a positive, and then 4 times 21 is 84 over 2. So 16 plus 84 is 100. So that's going to make it easy. So we have x equals -4 plus or minus the square root of 100 over 2. Well, the square root of 100 is 10. So -4 plus or minus 10 over 2. So that's going to give us two solutions then. So we'll have -4 minus 10 over 2. So that's -14 divided by 2 is -7. And then we have -4 plus 10 divided by 2. So that gives us +6 divided by 2. So our solution set for this is -7.3. All right, let's look at this one. So we're just going to subtract the 24 from both sides. So that gives us x squared minus 2x minus 24 equals 0. And we have A is 1, B is -2, and C is -24. So x then equals -2, because B is -2. The subtraction signs, just remember they're the same as plus, negative. So that's why we make that a -2, plus or minus the square root of -2 squared minus 4 times A is 1 and B is -24. All over 2 times 1. All right. So let's move up here. So this is going to give me, I'm moving right there. It's going to give me x equals -2 is 2 plus or minus the square root. And then I have -2 squared is 4. And 2 negatives make a positive. And then 4 times 24 is 696 over 2. So we again get 100 in this. So we get 2 plus or minus the square root of 100. And that's just going to be 10 over 2. So that's going to give us x equals 2 minus 10 over 2. And that would be -8 over 2, which is -4. Or we have x equals 2 plus 10 over 2, which is 12 divided by 2, which is 6. So for this solution set, we're going to have -4, 6. All right. That means in both those cases, the parabola intersected the x-axis in 2 locations. So now we have a frog jumping into the air. According to the English unit's velocity formula, y equals -16t squared plus 10t plus 0.3. So how many seconds is the frog in the air before landing? So we see, well, we have A equals -16, B equals 10, and C equals 0.3. But you might ask, what am I doing? Well, I am going to set this y to 0 because when the frog jumps, and we have a y value here, y will equal 0 when the frog hits the ground. So we can use the quadratic formula by saying this is 0 equals -16t squared plus 10t plus 0.3. So instead of blindly applying the quadratic formula, this is actually what we're doing. We're trying to find when the height is 0 again, that's how long it took for the frog to jump. Okay, so, and t is in seconds. So now we have t, remember we're not using x all the time, equals negative b, which b is 10, so negative 10 plus or minus the square root, and then we have b squared, so 10 squared minus 4 times negative 16 times 0.3 all over 2 times negative 16. So in this case, a is negative 16. All right, so we have t equals negative 10 plus or minus the square root of 100. We have two negatives again, so that makes that a positive. All right, 4 times 16 is 64. Let's do 64 times 0.3. So that's 1219, and then that's 19.2 because we moved the decimal one place over. So we have 19.2 here, all over negative 32. All right, so let's write this right here. T then equals negative 10 plus or minus, and the square root of 119.2 over negative 32. All right, so let's see what the square root of 119 is. Okay, so the square root of 119 is 10.9. And then we're dividing that by negative 32. Now, this negative, I have two negatives here, so that's the same thing as 10 over 32. And then when you have a plus or minus, that just makes it, well, we still have a plus or minus, but it's going to be 10.9 over 32 because the negative gets a little lost in the plus or minus, okay? We don't flip the minus plus, it's still plus or minus. So now we need to figure out, well, what is 10 over 32? So 10 divided by 32 would be 0.3125, and then plus 10.9. Oops, let me just grab that number. Okay, so then we'll use that and divide by 32. So mine will be a little more specific because I actually grabbed the number I got from the square root here and then divided by 32. So 0.34. And you notice it's plus or minus here, but if I subtracted 0.34 from this, I'd have negative time. So we aren't going to do the minus because we can't go back in time. The frog is jumping forward in time. So we're going to add these two together. So when we do that, we get 0.6525. So if we want to round that to the nearest hundredth, that's 0.65 seconds. Okay, so that's how long the frog was in the air. All right, so let's go ahead and look at the next problem. So we're only going to use the discriminant to find this. So how many solutions or roots again are the same thing as solutions. Roots are where does it hit the x-axis. Okay, so that's why we set it to 0, because y is 0 when the parabola hits the x-axis. So a here equals 1, b is -10, and c equals 25. So if we look at b squared minus 4ac, we have -10 squared minus 4 times 1 times 25. So this is 100 minus, and that's also 100, so this equals 0. So that means we have one solution. So if we're looking at this parabola, and this is not going to be drawn, this is x minus 5 squared. So it's going to hit right here at 5. So the parabola is going to look like this, where it just hits in one place on the x-axis. So this one, we can keep all the negatives, or you can actually divide everything by -1 and make it positive. It doesn't matter. So this a here is -1, b is -6, and c equals -10. So if we put that into the discriminant, we get -6 squared minus 4 times -1 times -10. So -6 times -6, which is -6 squared, is 36. I have 3 negatives, so that's going to remain negative. If you ever have an odd number of negatives multiplying, it's negative. If it's an even number of negatives, it's a positive. So 4 times 1 is 4. 4 times 10 is 40. So we get a -4. So what that means is there's no real solution, and the parabola, which is going downward from this direction, and it doesn't ever hit the x-axis. So it's actually down here at -10, and I'm just making an approximation on this one. It may not be right. It may be in this quadrant, but it just won't hit the x-axis. So that's what no real solution looks like. So there are imaginary solutions that you'll learn about in algebra too, but right now we're just going to say no real solution. So on this one, we have A is 1, B is 1, and C is -6. So let's see what we get when we do the discriminant for this. So we have B squared, which is 1 squared minus 4 times 1 times the -6 for C. So this is 1. I have 2 negatives, so that's a plus. And then I have 4 times 6 is 24, so I have 25. So I have a discriminant. So that means I'm going to have 2 solutions. Okay, so what this parabola looks like when you have a number that's not 0, you have 2 solutions. So when you're looking at the quadratic formula with this plus or minus, it means there's something in here. So you're going to have to add or subtract from this -b, which creates the 2 solutions. So that's the maximum number of solutions for a parabola. It can only hit the x-axis in 2 solutions. So that means if we look at this, we know it's opening up and it's hitting at 3, -2. So if we look at this one, yx, it's open 3 and -2. This parabola is looking at, and it goes down to -6. So it looks like this. So it has 2 solutions right there. So this one's no solution, 1 solution, and this one is 2 solutions. Okay, well, that's it for this section. You have a wonderful day. Bye-bye.